Welcome to part 3 of the lecture series on number theory and computations. For this video, we'll be looking at prime factors and lowest common multiples. First, what are common multiples? Common multiples, as the name implies, is a multiple that is common among a given set of numbers. For example, what are the common multiples of 4 and 8? Well, to do this, we can list the multiples of 4, and like we did in the previous lecture, we get 4 multiplied by 1, 4 is a multiple. 4 multiplied by 2, 8. 4 multiplied by 3, 12. 4 multiplied by 4, 16, etc. And the multiples of 8, when we work it out, are 8 multiplied by 1, 8. 8 multiplied by 2, 16. 8 multiplied by 3, 24, etc. Upon examining the multiples of 4 and 8, we see that the common multiples of 4 and 8 are 8, 16, and if we extend the multiples of 4 a bit with 4 multiplied by 5, which is 20, and 4 multiplied by 6, we see that 24 is another common multiple between 4 and 8. Now, the 8 in this case is the smallest of all the multiples of 4 and 8. And this is called the lowest common multiple, or LCM, which is a very special term in math. So let's give a formal definition of the lowest common multiple. If we have a set of numbers, then the lowest common multiple, or LCM, is the smallest number that is a multiple of every number. Let's do another example. What is the LCM of 3 and 9? Well, the multiples of 3 are 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18, etc. And the multiples of 9 are 9 multiplied by 1, 9. 9 multiplied by 2, 18. 9 multiplied by 3 is 21, etc. So the lowest common multiple is just the smallest multiple that is common between both the multiples of 3 and 9. And we see that this is 9 in this case. Now let's look at a second example. The LCM of 15 and 18. The multiples of 15 are 15, 30, 45, 60, etc. And the multiples of 18 are 18, 36, 54, 72, etc. So looking at both, I don't see a multiple in common. So what we can do is extend the list of multiples of 15 to add 75, 90, and let's add 105 as well. And we can also extend the multiples of 18 to add 90. Okay, so now we see a common multiple, and the lowest one at that, which is 90. So the LCM is 90. A much easier way to calculate the LCM is with prime factors. So this presents another great use for prime factors. So using a similar table method like from the previous video, we're going to find the LCM of 15 and 18, which we already just proved is 90. So we have 15 and 18 in the table, and what we do is think of a prime number that divides into 15, 18, or both numbers. Personally, I want to focus on just one number, so let's use 15. The prime factor that we'll use for 15 is 3, right? That seems pretty simple. And 3 goes into 15 5 times. But we also have to keep in mind that 3 is also a factor of 18, and 18 divided by 3 is 6. So now we're left with 5 and 6. Okay, so let's focus on 5. The prime factor that divides into 5 is 5. And 5 doesn't go into 6. So we write back the 6. We just ignore it and bring back the 6. Now we're finished with one side. And we're left with just 6. 2 is a prime factor that goes into 6, and it does so 3 times. And 3 is the only prime factor for 3, and it goes into itself once, leaving us with 1, and we're done. The LCM is just the product of all the prime numbers. So 3 multiplied by 5 multiplied by 2 multiplied by 3, which is 90, exactly what we expected to get. A second example. Let's find the LCM of 15, 18, and 20. So we drop the table, and our prime factor that goes into 15 is 3. 15 divided by 3 is 5, but 3 is also a factor of 18, and that goes into it 6 times. And we bring back the untouched 20 since 3 isn't a factor of 20. Next, 5 goes into 5 once. We bring back the 6 since 5 isn't a factor of 6. But 5 is a factor of 20 and goes into it 4 times. Now we're left with 6 and 4. 2 is a factor of 6 and goes into it 3 times. But it is also a factor of 4 and goes into it twice. So now the only prime factor of 3 is 3 and it goes into it once. And we bring down the 2 since 3 isn't a factor of 2. We're left with 2. And the only prime factor of 2 is 2. Now we're done. So the LCM of 15, 18, and 20 is a product of all the prime numbers. 3, 5, 2, 3, and 2, which is 180. Now for the last example, I want you to find the LCM of 6 and 8 on your own. So pause the video right now, solve it, and when you get the answer, unpause and we'll see if you got it right. So I'm assuming that you got an answer. Let's see if you're right. When we draw up the table, we start off with a 2, and that goes into both 6 and 8, leaving us with 3 and 4, respectively. Then let's go in with another 2, and we put back the 3 since 2 isn't a factor of 3, but 2 divides into 4, and that goes twice. So we put the 2. We can also have another 2 again, so we write back the 3, and 2 goes into 2 once. And now we're left with 3, and the only factor of 3 is 3, so we're done. Which means that the LCM is 2 multiplied by 2 multiplied by 2 multiplied by 3, which is 24.